Okay, welcome back. This is the second part of the video lecture for section 1.5, and as I mentioned in the last video, we are going to be continuing our conversation on using the substitution method, but in this video we're going to discuss how to perform the substitution method for definite integrals. So you can see the theorem here that addresses that, and the main thing to note is that the method is pretty much the same, except now instead of having limits of a and b, we'll now have our limits be in terms of the function that we use to make the substitution. So basically, we just need to change the limits. And I'll show you how that's done here in example 2. So again, just like with indefinite integrals, we're going to perform our u substitution. We're going to pick that inside function. So u is equal to x cubed plus 1. And then du would be 3x squared dx. And notice that 3x squared dx is in the problem. The derivative, the derivative of u needs to show up somewhere else in the problem in order for this to work out. This means then that dx is equal to du over 3x squared. And so when we go to substitute here, we have the integral. We'll deal with the limits here in a second. I have 3x squared. I now have the square root of u, and then dx is going to be du over 3x squared. And then to change the limits, we're going to use that u function that we had. So it looks like this. So our limits were x equals -1, that was the lower limit right here. And then x equals +1 is the upper limit. We basically just plug those into our function. U is equal to x cubed plus 1. So in this case, when x equals -1, u is equal to -1 cubed plus 1, which is 0. And then in the case of x equals 1, u would be 1 cubed plus 1, which is 2. So that's how we change the limits. And so we can go ahead and factor that into our problem. So this limit, lower limit is now 0, and the upper limit is 2. Also note that the 3x squareds cancel, so this 3x squared cancels with this 3x squared. And so this whole integral gets a whole lot more simple. We now have the integral from 0 to 2, and all that's left, after all that, all that's left is the square root of u, and I'm going to rewrite that again as u to the 1/2 du, and now we can simply just use the power rule. So we add 1 to the power, we get u to the 3/2, and then we divide by 3/2, which is like multiplying by its reciprocal 2/3, and we're going to evaluate that between 0 and 2. Then we use the fundamental theorem of calculus, and we go ahead and plug in those limits, and we get 2 to the 3/2 minus 0 to the 3/2. Which of course is 0. So this is going to be 2/3 times 2 to the 3/2. You could simplify that a little bit, because 2 to the 3/2 is 2 root 2. You could simplify that to 2 root 2. So you could also write this as 4/3 times the square root of 2. That would be the most simplified answer. Okay, so there's one example. I'm going to do one more here. So we have part B of this example. Again, we're looking for that inside function, and you want to think about it in such a way that the derivative is somewhere else in the problem, because the derivative of that u has to be somewhere else. And so a couple things we want to kind of discuss here at the beginning. Just kind of a notation thing. Let's remember that whenever you have something like the tangent squared theta, notation-wise, that means the tangent of theta squared. And then, of course, the same thing goes for the cosine squared theta. Cosine squared theta is the same as cosine theta squared. So really, we're going to let u equal either tangent or cosine, because tangent or cosine are inside functions. So if we let u equal tangent theta, then du is secant squared theta. Oh, I'm running out of room there. Let me rewrite that below here. And du is equal to secant squared theta d theta. Or if we choose the second one, if we let u equal cosine theta, then du equals negative sine theta d theta. And so we have to ask ourselves, between those two choices, choice 1 versus choice 2, which works out better in the problem? So we could choose either one, but notice, remember, the du part, the secant squared or the negative sign, has to show up somewhere else in the problem. The negative sign does not, but the secant squared does. It doesn't show up. It's not real obvious, but it's there, because when you look at cosine squared, remember the reciprocal of cosine squared is secant squared. So let's see what this looks like. Let's choose the first option. We will go ahead and choose this one right here. So if I go ahead and rewrite this, let me change colors to blue here. If I go ahead and rewrite it, I get the integral. And again, remember, we're letting u equal tangent theta. And so instead of tangent squared, we're going to have u squared. And then we have over cosine squared. And then d theta, if we solve this du for d theta, we get that d theta is equal to du over secant squared theta. And we'll go ahead and change our limits. If theta is equal to 0, then that means u would be the tangent of 0. And the tangent of 0 is 0. And then if we use the upper limit of pi over 4, the tangent of pi over 4 is 1. Let me write those down. So, again, 0 is 0, and the tangent of pi over 4 is 1. So those are our limits. And then, like I said, remember, cosine squared theta is equal to 1 over secant squared theta. Those are reciprocals of each other. So really on the bottom here, when I take a look at the bottom of this integral, cosine squared times secant squared, these are reciprocals, so they cancel each other out. This will cancel with this, and so this integral just becomes, it actually simplifies a lot, it just becomes the integral from 0 to 1 of u squared du, which is a simple power rule problem. raise the power by 1, u to the third, divide by that power. We're going to evaluate that between 0 and 1. And when we do that, we get 1/3 is our answer. So hopefully you feel like those two examples give you a good idea of how to perform u substitution with limits, or when we have a definite integral. And I will post also another document that has the extra practice solutions worked out here. We're not going to go over these in the video, but make sure you look through those, get the practice that you need. Also, I will, after you look through that, make sure that you go and start the homework in the week 1 module. Reach out if you have any questions, let me know. Have a great day. Thank you.